So those are the two announcements, and so I'm happy to introduce our third and final keynote speaker for the conference. Dr. Chris Boehnen is a Senior Program Manager at the Intelligence Advanced Research Activity, which is not an agency, it's IARPA, where he's focused on biometrics, computer vision, and machine learning. He's the program manager for Odin, Janus, and the BEST programs, as well as the Nail to Nail Challenge, and he'll tell us more about challenge programs here. Before IARPA, Chris was the lead of the secure computer vision team at Oak Ridge National Labs, where over 6 years he was the PI for $11 million in funded projects. He received an early career award for engineering and several Best Paper awards, including at BTAS 2016. Chris got his bachelor's, master's, and PhD degrees from Notre Dame, and very importantly to our community here, Chris published some of his early work here at WACV, so it's great to see him continue to be engaged with the community, and it's nice to see somebody from WACV move on to a nice, important job. So without further ado.
Well, thanks, and thank you to all the conference organizers, including Terry, who somehow managed to avoid being listed as a conference organizer, but deserves more credit than his lack of listing suggests. Yeah, my first publication actually was at BTAS back in 2004. I'm not a very academic-oriented person these days, but a discussion on citations yesterday led me to look it up, Terry, and I had 74 citations on that publication, so that's not bad. So I'm a program manager at IARPA, which means I'm not the one doing the research anymore. For those of you unfamiliar with IARPA, we're under the Director of National Intelligence, so we serve the entire U.S. intelligence community. These include parts of the community you think about and see in movies all the time, like CIA, NSA, but it also include parts that you probably don't think about, like Treasury, Department of Energy, State, and more. So all of these are different branches of the intelligence community that my organization supports. IARPA is not operational though. So all we do is research. So we're not actually out there catching bad guys ourselves. We're out there developing a technology that other people is going to use. If you're familiar with DARPA, IARPA was set up and modeled after DARPA, with the primary difference being that we serve the intelligence community and DARPA serves the Department of Defense. But fundamentally, what both organizations do is perform high-risk, high-reward, cutting-edge research. Now, with that in mind, I was asked to talk about prize challenges and their role in computer vision here today. So I want to start with a simple question for everybody. Do me a favor, raise your hand if you think the research you do is the best. And if you don't raise your hand, I'm going to throw you out of the audience, because if you're a researcher at a conference like this, you better think your research is the best. Now keep it up, all right? And keep it raised if you've ever proposed something that you think should have been funded but wasn't. If you're a grad student, it doesn't have to be proposed. It could be you said to your professor, I want to do this, right? And the professor said, no, that's a dumb idea, right? Most of us should have our hands raised. All right, now keep your hand raised if you think everyone who has their hand raised is right. Did they all have a good idea, or were some of them bad ideas? Yeah, safe bet that some of them were bad ideas. So if you have your hand raised, I'm willing to argue with you over a beer, but I am willing to bet with a crowd this large, at least one of us who thought we had a good idea really didn't. And you know, that's a fundamental problem in research from my perspective, right? So my job in life these days is to review research concepts and determine which ones to support. And the challenge is there's simply more good ideas than there is funding to support it. And so what that means is people just like me have to review these proposals and figure out which ones we think are right. The problem is we're not always right. And it's not just us program managers. This concept goes back a long time. If you've ever heard of, and I'm going to butcher this poor gentleman's name, Inez Semmelweis, he had a radical idea as a medical doctor. He thought you needed to wash your hands after visiting the morgue before you went to see other patients, right? He tried to convince all of his colleagues that this was a really good idea because people were, for reasons he couldn't explain, much more likely to die if you didn't wash your hands. His colleagues all said, you're crazy. Why would washing your hands affect patient outcome? They didn't know anything about viruses, bacteria, et cetera at the time, right? So Inez finally actually managed to convince a few people to try it out. Turns out it lowered mortality by a factor of 6. So 6 times less people died if you just washed your hands. But he couldn't convince anybody to do it. So he had a great idea, but couldn't convince anybody to do it. I'm willing to bet if I could actually convince you all that you should wear a baseball cap by doing your research, and you'll be 6 times more likely to win a Nobel Prize, you would all wear a baseball cap if you believe me, right? Now, in that case, I have no idea why wearing a baseball cap is going to help you, but the point remains, right? The challenge with trying to figure out what's a good idea and what's a bad idea is it's very hard to do and we don't always get it right. This is where challenges can come into play. They're much more democratic. So with a challenge, anybody with a good idea, regardless of your credentials, regardless of where you're from, can participate. And hopefully, if done right, participate on an equal playing field. So this gives us an opportunity to really figure out what the good ideas are. It also tends to be more cost effective as somebody who runs these things. Now, the reason is ironic. It's because we're not paying anybody to do the research. So we cut out a big chunk of the budget there. It's fair, as we mentioned, right? If you're that person who has this crazy idea that is actually correct, you can prove it out. Challenges can typically have very clear goals and outcomes, and they can allow for a very direct comparison and quantitative analysis of how different approaches compare. Done right, they can provide an ongoing representation of how things go, right? More and more, we're seeing challenges where there are constant leaderboards that you can submit to constantly, as opposed to fixed periods in time when we find out how something works. And they tend to generate some public interest, right? There's kind of this fun idea of competition that gets in there. Now, within the field of computer vision, we've actually had some pretty significant challenges that have really driven the field. For those of you remember back in the early 2000s, the DARPA Autonomous Vehicles Grand Challenge, Prize Challenge. By the way, challenges can either have money associated with them or not. In the case of DARPA, this one did. Are pretty much why we have all of this self-driving car work going on today, right? So DARPA came out with an idea. Hey, we think a car can drive itself. I don't know about the rest of you at the time. I thought they were a little crazy. Not that it would never be possible, but their timelines were amazingly ambitious. But it actually propelled the state of the art. I've heard a lot of deep learning discussions at this conference, right? AlexNet, which I view as really the leading motivator for a lot of the deep learning work we're all doing, came out of the Imagenet challenge. So, you've got another challenge there. Closer to my own heart, Labeled Faces in the Wild is a biometric challenge that really has done a lot for face recognition. So these challenges have really been helping us propel the field forward. And so what makes a successful challenge? Well, the first thing is you need a clear goal, right? If your challenge is, I want to make computer vision better, you're not going to get anywhere, right? That's not a concrete, testable challenge, which leads to the second point, which is you really need an impartial test environment. You need a way of quantitatively comparing how these things work. A lot of times you have unique data sets. So bringing new data to the problem allows you to look at it in a new way. You need to somehow get researchers to participate. Remember, you're not getting paid to participate. You might win money in the back end, but you're not paid just for showing up. So you need a way to get all these researchers excited about it. And commonly there are new enabling technologies that kind of allows for some of the breakthroughs that we see. If you look at a more specific example of where these elements are in, say, the AlexNet Imagenet challenge, you had a very specific data set and test environment from the Imagenet team. You had a smart researcher motivated to participate. Give me 1 second here. Oh, it's just on my screen that the computer's crashing. That's wonderful. Give me 1 second, folks. Nathan, your computer might be killing me here. Let's see if this works. All right, so, and we had enabling technology. So with that in mind, prize challenges sound like a great solution, right? So do me a favor, raise your hand if you're willing to work for free the rest of your life. All you need is science, and you will sleep outside and beg for money. Nobody? Okay, so prize challenges aren't perfect, right? There are some disadvantages to the prize challenge model. Typically, even when there's a prize associated with it, if you win money, that's not enough money maybe to cover the cost of the research if you're lucky. So it's really not a feasible long-term business model, if you will, if you're interested in this. They tend to work well for sprints. but the challenges themselves tend to be obsolete over time. So labeled faces in the wild was a great data set and a great challenge. At this point, I am completely uninterested in hearing how many nines of accuracy you can achieve on it. It was a great data set, but the technology has kind of moved on and needs to be updated if you're going to really keep using it to drive state-of-the-art, and this is a common problem as well. You also have a limited ability as the organizer of the challenge to influence the build process, right? People are going to come up with what they're going to come up. It may be irrelevant to your goals. It may, in fact, even be counterproductive to your goals, but that's all things you have to accept. Now, if you're a researcher, I'd encourage you all to participate in prize challenges. It encourages collaboration. Commonly, you can gain access to data that you wouldn't otherwise have. You can get publicity. The spirit of competition can be fun. You might win some prize money. At IARPA, I'm going to talk about a couple different prize challenges that we've done in about the last year, and I'll give you a hint about a few that are up and coming. 4 of these are mine, and 2 of these belong to an associate of mine in terms of funding. When I say mine, that doesn't mean I deserve the credit for them. For example, Walter, who's sitting right there, is the brainchild behind UG2 and deserves most of the credit. I just write checks, and he does good things. So keep up the good work, Walter. One of the challenges is the Multiview Stereo 3D Challenge, led by Hawk J. Kim. We'll talk about that. There's a face recognition prize challenge we recently completed, the Nail to Nail prize challenge. UG2, we're sponsoring just the prize purse for the Disguised Faces in the Wild competition, and Hawk J is just about ready to announce the winners of his Functional Map of the World prize challenge. So, UG2, oh man, now I have to remember what it stands for. It stands for Unmanned No UAV, what's the other one? All right, UAV glider and ground. Remember, it's Walter's prize challenge, so I don't remember how he named it. But it's up and coming, and I'll point out this is actually one of the prize challenges we have where it's still open to competition. So if you want to participate in this, you just have to register by April 1st, so you have plenty of time. The focus of this challenge is to look at image enhancement techniques. So certainly we've all laughed at CSI when it's had this image and they zoom and enhance and all of a sudden 2 pixels is now 1,000 pixels and you can see somebody's face, right? That said, there is a lot of potential to enhance and increase the quality of video with various computer vision computational photography techniques. And the goal of this challenge is to specifically look at that from a, primarily aerial, but also there's some ground data in their perspective. So the question is, can you come up with some pre-processing routine to improve the quality of the imagery? Now, in the spirit of what we've talked about here, we've got a new data set. So there's a new data set that includes controlled data that Walter and his team captured, glider data that they actually had a local group give them access to, and then YouTube UAV data that's just completely wild and uncontrolled. So we're looking at all of this. So we've got a standardized data set the community can use beyond the challenge itself. And then the question becomes, well, what are we actually going to look at? So one of the ways that Walter is going to be evaluating this is looking at the impact on object detection or classification. So it's certainly plausible that we could have image enhancement techniques that could cause the image to look better to us as a human being. So for example, you can see from the original image, maybe it's hard to tell in this image, but this one is fairly blurry, and you can run enhancement techniques that to a human appear to improve the quality of that imagery. The catch is, to certain pre-trained classifiers, that improvement actually causes you to get an incorrect detection or classification, because while it may have improved it to the human eye, that doesn't mean it's improved it to an algorithm as well. So that kind of brings to play the 2 different challenges or focuses within this prize challenge, which is image enhancement for manual inspection. So this is human beings who are going to look at this data and try and do something with it, or image enhancement for automated object recognition. I don't think it's a surprise to any of us, but computers and deep learning in particular, the way it looks at these types of imagery and processes it is very, very different from how a human being does. Adversarial imagery is a classic example of this. Changes that are literally undetectable to us as a human can have significant impacts for the resulting algorithms. And so, the fundamental challenge we're trying to look at for this particular prize challenge is, can we develop techniques that are going to improve the imagery from a algorithmic perspective as well as human perspective? This is not a given that this challenge is going to be successful, which is part of what makes it such an exciting challenge. I'll tell you, within the Janus program, we've looked at face recognition, and a well-built face recognition system with appropriate training data doesn't appear to benefit from most of these types of enhancement techniques today. And the question becomes why, right? And this gets into deep understanding of deep learning versus just applying it. What is deep learning doing under the hood that is negating some of these techniques that we think should be powerful? So I would encourage all of you, for this prize challenge in particular, to go look it up and consider participating. If we can get a positive outcome here, it will be a very impressive feat and open up some new areas of research. And if the science alone doesn't get you, there is $75,000 in prize money and a personal attaboy from Walter in it for you when you succeed. So not too late. Please consider signing up. Another prize challenge that was recently completed, run by Hak Jae Kim at IARPA, focused on multi-view stereo 3D mapping. So the question was, how can you use overhead imagery that would come from a source like a satellite and produce 3D point clouds of the resulting models? Now, in order to facilitate this challenge, Hak Jae went ahead and actually had some ground truth, I believe it was LiDAR style scans of various cities affiliated with the imagery. So he was able to produce a unique data set, right, to test these different techniques, release, not only ground truth, but source material, and then analyze all of it. And the other interesting thing worth paying attention to here is the groups that won, right? You've got, in first place, kind of a research group, but some of the other folks were just kind of lone wolves who on their own worked on interesting solutions and succeeded. And that comes back to my initial comment on the challenge with picking who's going to be good at something or not. Because all too often, if you have a research idea and you're just a guy in a garage, it can be pretty hard to get attention and support for it. But with a prize challenge, you really can. So if you're a grad student living off of ramen, spending a little bit of extra time on prize challenges could earn you what to you is some pretty serious cash. So this prize challenge just concluded and found some good results. They also made a big effort to release all of their solutions open source for the winners. That's something that some prize challenges will make a goal and some will not. It kind of varies. Another challenge that the winners haven't been announced yet by Hak Jae, but is up and coming, it's going to be announced fairly soon, is the Functional Map of the World Challenge. So there, once again, Hak Jae created a unique and new data set. In this case, it consisted of multispectral overhead imagery, along with some classification. So the goal here was, can you, well, not necessarily can you, how well can you classify maybe the use of land in the case of something like this, or the purpose of an individual building or location. And they have a large amount of data. They've got ground truth. And from what I've heard from him, there's going to be some really interesting and impressive results coming out of this. But for both of these challenges, it's not just the initial challenge that's making the contribution to the research community. It's the long-term, long-lasting impacts that matter. In the field of face recognition, the government, and NIST in particular, has been very good at testing vendor solutions, right? So if you follow face recognition, the face recognition vendor tests happens every few years, and most of the large commercial companies at this point are highly pressured to participate in order to show how well they do. That's not necessarily true for all the research systems. And so in conjunction with NIST, IARPA ran the Face Recognition Prize Challenge to try and understand what is the state of the art of face recognition performance today, both from a research and commercial systems perspective, to allow everyone to compete on an even playing field of new and challenging data sets. Within that, we had a few different tracks of challenges. So these included a speed prize, although when you design these challenges, you have to think these things through, which we did here, right? So it's not just fast, it's got to have some minimal level of performance. So out of all of the initial submitters, we thresholded the ones to make sure you had a high level of performance, and then we looked at how fast the solutions were. Now, what's interesting is you see many of the performance is roughly linear, right? So on the x-axis here is the number of subjects, in your gallery, and on the y-axis is time. And we looked at everything from template creation to search time to total time. But what was particularly interesting is actually one of the performers actually managed what's sublinear pretty close to logarithmic search time. That's something that, I'm not sure I would have thought we were really at yet, not that we wouldn't have gotten there. Now, for those of you who don't follow biometrics, this is pretty powerful. This means that really you can have galleries pretty much as big as you want with a minimal impact on search time. And in fact, the company who won first place for the time prize, Entech Labs, is a Russian company, and they actually work, for example, with the city of Moscow to try and run face recognition, across supposedly all of the surveillance cameras within the city of Moscow. So they as a company, it makes sense, would really care a lot about, extremely high-performing solutions. Another advantage of prize challenges when dealing with these commercial companies is that we can entice them to share things that they may not otherwise want to share. We don't force them, but we encourage them to give talks. So, for example, Entech at their talk revealed how many subjects and images they have in their training set. Anybody want to take a guess? Because I was blown away. Terry, how many subjects do you think they have? They have 400 million subjects with over 4 billion images. Okay? So, you want to talk about a large data set they're using to build their set, it's pretty big. They're a little cagey about where they get their data, although it's pretty clear that they get their data, at least in part, through the Russian version of Facebook and Match.com. So they have, partnered with companies who have access to these large data sets that they are then able to utilize. I don't know about the rest of you, but I just drool over the concept of 500 million people worth of face images to use for research. So I don't know how to fix that one yet. If anybody actually thinks they know how to get me 500 million images for you guys to all use in the research community, come see me. But prize challenges allow us to have an even playing field where we can try to understand how these 500 million subject approaches work with everybody else. Now, we also looked at one-to-one or verification performance within the FACE Prize Challenge. And here you can see, this is a nice rock curve if you're not familiar with rock curves, where you've got the false non-match rate on one axis and the false match rate on the other. As with any rock curves, just trust me, down here is where you want to be, up here is bad, okay? We picked an operating point that we felt was appropriate for a variety of real-world applications, and then looked at who was the best. Turns out Entech, who also won that speed prize, was comfortably the winner for the one-to-one verification approach. Now you can see a variety of other companies' performance as well. Worth noting is I'm going to be talking about Yi2 in a minute because they won the other prize, and you can see they're right over here. And NIST, actually, if you're interested in more results on this, has released a wonderful geeky report. I think it's 100 pages or something with very in-depth analysis of performance on different aspects of this. So we also, as I mentioned, looked at recognition accuracy. So this is 1 to n. This is a large search. And what we did was we took the largest gallery we could manage to use for research purposes, which in our case was 700,000 about for the search. We also actually allowed the performer teams to submit 2 different versions of their algorithm, primarily because some of them wanted to submit GPU or CPU versions. Yi2, which is the company who won this particular challenge, did the best for both their CPU and GPU version. Entech wasn't too far behind. You can see this is Entech. So basically, Yi2 and Entech kind of switched performance metrics here, depending on if you're in verification or recognition. But it's worth noting that there were other differences in performance between these two sets because we didn't use the same data set for testing for verification and recognition. So within the field of face recognition, depending upon the type of imagery you're using, it can really pretty significantly affect different algorithms' performance. So for the verification challenge, we focused on a wild internet style image set as the basis. So this is imagery that you'd find on a site like Facebook or something like that. For this challenge, we actually used a set that was more oriented towards surveillance cameras. So it's a subtly different flavor of facial imagery that affects performance. And that flavor, so the differences aren't necessarily just verification versus recognition. I'll also give you all a little teaser of an idea I've been kicking around for a prize challenge. It's not formally launched yet, so this is not a commitment that it's going to happen. But I think it would be very interesting to look at feature-level fusion of different face recognition systems. So, the question becomes, if you have an extremely important application and you're very worried about getting extremely accurate face recognition results, and you're willing to run, say, the top 5, and top 5 may not necessarily mean the 5 best, because in conjunction it could be different, but so you're willing to run a whole bunch of different face recognition algorithms, how would you use them in conjunction with each other? And the challenge we have today is we're pretty much limited to score fusion. And the reason is most of these commercial companies are pretty reluctant to let you in on their actual features under the hood. So what we're going to be looking to do is leveraging several of the different state-of-the-art research systems we have, and perhaps release feature sets that you could then experiment with for fusion to try and see how would you use these different techniques together. There's a lot of evidence that this is pretty powerful stuff. University of Maryland, who leads one of the teams in the Janus program, actually has several different neural nets that they already fuse together to increase their performance. But the question is, how would you do this really across a wider spectrum? So if you think that's interesting, pay attention, because we may be releasing a prize challenge in that area of face in the near future. Another challenge that we did, which we're going to be announcing next week, was the nail-to-nail fingerprint challenge. Now, this was a very different type of challenges than many of the ones we see in computer vision, in that there was a significant hardware and data collection approach. So all of the challenges that I've talked to up until now include a static data set that gets analyzed for the challenge. In this case, what we were interested in was understanding how it might be possible to create a better fingerprint collection system. So today, if you want the best fingerprints, the FBI will tell you that what you want to do is you want to roll the fingerprint. So when you see in the movies and there's like ink and there's somebody who like grabs your finger and like rolls it and then rolls it over, that's rolled fingerprint capture. Now, one of the big reasons they do that is to capture the sides of the fingerprint, which is believed to be fairly important traditionally for latent fingerprint recognition, because if all you've left behind is the side, then you don't have the bottoms or the slaps to recognize things. Now, another thing to think about when you're crafting your challenge is, what is your real goal? And this came up in the case of the nail-to-nail challenge. So when we were formulating this challenge initially, a lot of our partners were expressing that what they wanted was a contactless fingerprint challenge. And I really pushed back on them and said, well, what is it about contactless that you want? Like, you're saying you want contactless. Why do you want it? Well, because contactless is the future. And I pushed back and said, why? They said, well, it'll get us better performance. And when you're formulating your challenges, you have to think, well, what's your goal? Is your goal to get the best performance, or is your goal to get contactless fingerprinting? Because if you were to have formulated this prize challenge as just contactless fingerprinting, you would have precluded a bunch of technologies that may be ideal for the solution. In this case, there really wasn't a reason to have it be contactless. The presumption on certain people's parts was just that contactless was going to be better. But if it doesn't matter, don't bake that into your challenge, right? Boil it down to the essence. So what we did here is, you can see this is a photo of the giant bay in which we captured the data. And along the edge of the room over here, there were different kind of booths. And in each booth, people were welcomed and encouraged to take their prototype or whatever fingerprint capture technology they wanted. And we had several hundred subjects go through and get captured at each booth. In addition, we also went ahead and had traditional latent fingerprints captured. So these stations right here in the middle are all focused on capturing latent fingerprints, and we had some experts from the FBI capturing rolled fingerprints the way that we do it today. And so, unlike a static data set prize challenge, in this one we had to capture the data as we went. Now I'll say that creates its own set of complications and challenges. You know, my poor team, myself included, had 12-hour days for about 6 days in a row to capture all this data, but it was pretty valuable. And then, similarly to the other prize challenges you've seen us run, we set up different tracks of prizes. So we had a grand prize where we had a variety of much more specific rules laid out, but the ultimate goal was the best usable latent fingerprint matching system. But it was set up with ambitious goals intentionally, so that if someone were to have won this prize, we would basically have an alternative way to capture fingerprints across the board. There would be no reason to do it the way we do it today. Then we said, all right, well, depending on your use case, we're in a workshop and applications conference, right? Depending on your application, you may care more about speed. You may be willing to sacrifice a little bit of accuracy for speed. So we had a speed prize, we had a latent accuracy prize, a gallery accuracy prize, and we kind of threw in these prizes here that were in essence just for making it to the final round. So the way that we actually ran this in practice is we had several different phases to make sure that we could accommodate everyone physically at the prize challenges. And you can see here's a list of the different teams who competed. For the two university teams, these were true prototypes. You know, one of their prototypes was in a cardboard box, right? And the entire point of the prize challenge is we don't care about that. That's fine. Now, we also had groups like MorphoTrack and Greenbit and Genetric who had relatively polished commercial products available, and they're all competing head-to-head. Just to highlight a few of the different sensors that were brought to the challenge, AOS had a system here where you waved your hand on this black box in the middle, and there were cameras pointing at it at an angle from either side. It then produced a 3D representation of the finger, which they then had to unroll because they had to be backwards compatible with how all of the fingerprints are captured today for recognition. MorphoTrack similarly had a non-contact system, although with just a single camera. So one of the things that was baked into this challenge was a belief that we shouldn't force people to capture the entire nail-to-nail representation. If they could get just as good of accuracy with a single view, who cares? So Morpho only actually had a single view, but captured excellent prints. This was actually one of the prototypes from Cornell. I actually thought it was very creative. They had a big camera on an arm that rotated around the fingerprint. And so you put your finger in this hole, the camera zoomed around, capturing views all the way around, and they then, from those views, created a backwards compatible 2D representation. But seeing as we're at a computer vision conference, I mean, in theory, they should have the optimal view angle for every piece of the fingerprint by doing it that way, right? Because they're slowly traveling all the way around. Genetric has a product which is kind of fascinating because they've combined the fingerprint capture device with an LCD screen. So you can see there's kind of an outline of a finger here, and they're basically trying to get people to roll their own fingerprints, right? Only they're trying to give you feedback on how to do it on the screen so that you get better fingerprints as you go. So these are some examples of the different sensors we looked at. Now, we collected 10 fingerprints on 330 subjects. We also captured over 57,000 latent fingerprints. And all of this data, in the spirit of prize challenges include data, is going to wind up getting released back to the research community. So when you go home, there is a fairly large latent and live capture fingerprint research set that we will be releasing. In addition to all the sensors that you've heard about, we captured a bunch of baseline sensors. For example, some of these were palm sensors to capture other portions of the hand that may be relevant to latent fingerprints. And we've got other various statistics on the population that we used. But But honestly, I think this prize challenge is going to wind up being just as important for the long-term data set release as anything else. Now, I'm also going to share you some anonymized versions of the results that we'll be presenting at next week. Incidentally, if anybody wants to come and see the formal announcement where we congratulate people on winning and they talk about their solutions and all that, that's happening next week. Feel free to come and talk to me. But these include some images, some sample images of some of the latents that we captured. These are intentionally real-world difficult latents. You know, one of the challenges with latent fingerprints is that many of the university sets that are captured are frankly too good. They're too pristine compared to what you see operationally. And so we tried to simulate real-world actions. You can see we've got some listings of different actions we had people do here in the bottom, and you'll see more on that later. And, you know, we captured all of those. Some of the latents were developed with black powder. So this is when you see on TV, they've got this kind of feather duster thing, and they're dusting it over. Some of the latents required chemical processing, which is done with fuming and a variety of other techniques. But we've got a whole bunch of latents looked at. So I'm not going to tell you who won, but I will show you the distribution of the winners compared to the baseline. It's kind of hard to see on this screen, but this the omega symbol, this one, represents the baseline. So this is how the existing rolled technology works today. And then what we did is we captured, you know, you can see some box plots of acquisition time. And in theory, no one had more than 5 minutes with any given subject because we had a whole bunch of subjects going through. Now, when you're designing a prize challenge, one of the things you have to think about is what is your metric for success? And in our case, for acquisition time, we incorporated median with a skew function to penalize outliers. That actually made a difference in who won first place here. So the median fastest time was from entry A at 59 seconds. But when you actually accounted for their skew, because they had a couple outliers that were really kind of killing them, subject B actually wound up with the first place in our speed trial. So, you know, as you set up your metrics, you need to really think about the unintended consequence. Did you want the median to be the best? Did you want the skew? I mean, these are things you have to design up front, because once you've got the results, it's too late. We also looked at live gallery matching. Oh, so I guess it's also worth pointing out that there were certainly plenty of methods involved in the prize challenge faster than how we do it today, which shouldn't be super surprising to anybody who's ever had their fingerprints captured via the rolling process. It's relatively time consuming. The next challenge we ran had to do with live gallery matching. So we looked at the question of, you know, if your goal is not latent fingerprints, but your goal is, I'm going to do controlled capture of a living individual in front of you, how does that compare to the baseline? Now, it's worth pointing out that we kind of correctly, in my opinion, gave an advantage to the baseline. And then what we actually did was we captured 2 baseline samples with 2 different people doing the rolling. And then for the baseline performance, in this case, the omega performance, the performance is operator A compared to operator B. But that means that we had the exact same process, the exact same sensor. So you have a kind of home court advantage to how we do it today. In one sense, that's unfair, because you can argue, well, if we'd started off doing it a different way, someone else could have had a home court advantage. But that's a little bit like when I see these papers about internet design that start with, step 1, destroy the internet and rebuild it from scratch. That might be an interesting academic discussion to have, but we're not going to do that. And we're also not going to do that in the case of fingerprints. We've got a whole bunch of legacy data that we have to be able to use today. That said, we still had one team who did very, very close to how we do it today. I think it's a safe bet that if you took away the home field advantage, Performer C would be on parity with how we do it today. So we did, in fact, find a team that has live gallery matching, very, very similar in performance to a much more complex method of capturing it today. Then we look at latent matching. This is kind of interesting because the home court advantage goes away here, right? Your reference samples that everybody, including the baseline, are matching to are latent fingerprints. There's no interoperability advantage. And in fact, Performer C, who remember was pretty close before, did slightly better. So, you know, there is a sensor out there, and if you want to know which one, you're going to have to wait because I'm not telling anybody yet, that does in fact do a better job capturing or matching latent fingerprints than how we do it today. Now, it's worth noting there's a few caveats here, right? We used a lights-out, fully automated latent fingerprint matcher. Many of the criminal cases that we see today have human markups and human adjudication involved, and so whether that would alter the performance remains to be seen. It's also worth noting that all of these sensors from A to H only work with fully cooperative subjects. All right, these are people willing to be fingerprinted. Many law enforcement applications, that's not the case. You've got somebody getting arrested who does not want to get fingerprinted, and the baseline method is applicable to that environment. So there are some differences. It's also worth looking just at a cumulative match curve. If you're a biometric person, it's a different way of looking at performance. You can see the green color here was not the baseline way of doing it today. That's the blue color, which is right below it. So there really is a difference in performance compared to how we do today. It's also, worth noting just how badly all of these approaches actually did on latent fingerprint matching, okay? We're talking, high levels, 8%, 8 to 10% recognition performance. That's much lower than a lot of people think about for how fingerprint recognition works today. And that's part of the fun thing about doing these prize challenges. You get to really understand how things work today. Now, if you dive into, well, why did the latent fingerprint matching really fundamentally do as poorly as it did, some of the specific activities, so 7A, which one was 7A? 7A was a circuit board. So we tried to see how good we could pull fingerprints off of a circuit board. The answer was not very, because we didn't get any matches off of that. So some of these activities, these real-world activities, were just not very conducive towards fingerprint matching. And a follow-on exploration is going to be, why is that? So what do we learn from this particular challenge? We learned latent recognition is much harder than we thought. We learned that there actually are existing alternative technologies to how we do it today that may be suitable for certain applications, and that there's clearly a lot more work needed on the algorithmic side. So that should be encouraging for all the WACV folks. I'm hoping one of you one day will be writing papers and presenting them here about how to make a better latent matching algorithm, right? And this is just to kind of thank all the folks involved. All of these folks were involved with the testing and capture of this prize challenge. So when you run a physical prize challenge like this, there tends to be a lot of work and labor involved. I'll also put in a plug for one other prize challenge. I don't have a slide on it, but it's worth mentioning. The Disguised Faces in the Wild prize challenge is ongoing. IARPA is sponsoring a prize purse for this prize challenge. So this is, in essence, a prize challenge focused on as you are intentionally or unintentionally disguising the appearance of your face, whether it's with those Groucho Marx glasses and funny nose and beard or whatever it may be, how are face recognition algorithms going to deal with that? That prize challenge is ongoing, although registration is closed. So if you didn't register, you can't participate, but if you've registered, please make sure you follow through. And that prize challenge is going to be held in conjunction with CVPR, as is UG2 when we get there. So I want to leave a little time for questions, but for closing thoughts here, I think prize challenges play a very important role in computer vision. We are able to learn a lot about them, and we're able to have a fair competition. The good news today compared to when I was a grad student is we're all much more free about sharing our code. When I was getting my PhD, if you'd emailed somebody and said, can I get a copy of your code, after they stopped laughing, the answer would have been, no, I'm not sharing my code. But today with things like GitHub, I think we're getting better at that, but it still can be fairly hard to fairly reproduce and compare one set of work to another. And with prize challenges, we're really able to have a fair bake-off and look at how all these things do. So I think prize challenges have been and will continue to be important. Just make sure if you want to run a challenge, whether it's a prize challenge or not, make sure you have a clear goal. Make sure you've got an impartial test environment. Probably get a fun new data set to play with, although that isn't always necessary. And make sure you've got a way to motivate the researchers to participate. Remember, none of you had your hands raised, so working for free is not inherent to most of us in the community. So you got to figure out a way to get people motivated. With that said, here's my contact information if anybody's interested in learning any more, and I'm happy to answer any questions, whether it's on prize challenges, any of the main programs we run at IARPA, or anything else I can help with.
I guess I'll get started with one to get the ball rolling, which is from your experience in doing these, what's the sort of best way to try to calibrate the difficulty of the problem so that you don't scare off people, you still want to have some threshold to saturation, like labeled faces in the wild,
Sure.
stuff like this?
So, I mean, I think there's, depending upon your application, different routes to take. One is you don't have to have a goal, right? I mean, you can just say we're looking for the best TDR at FAR, you know, whatever your metric might be, and not actually calibrate ahead of time where you're going to wind up in the data set. So that's one way to do it. Another way to do it is to try and make sure that whatever your end goal for the technology is. So if you're looking at, say, DARPA's self-driving car challenge, you know, they said we want it to complete 60 miles worth of the course, right? And so they had a reason for that. So you can calibrate it either way. I think depending upon your goals with the challenge, one way may make more sense than another. So in the case of nail to nail, we kind of did a mixture, right? We said, all right, we're going to have this grand prize, this $100,000 thing, where you've got to be as good or better as what we have today. And then you've got these sub prizes to keep people interested in case that's not achievable. But you know, depending upon how you want to do, you can certainly go either way. Will it scare people away? You know, I don't know. There's certainly an argument to be made for making it as hard as you can to challenge people, and there's certainly an argument to be made for making it easy. Personally, I'd advocate for hard. If we're going to do these things, let's try and push the state of the art. I would rather have 5 quality participants than 100 mediocre ones. But, you know, up to you.
Chris, the latent fingerprint challenge, was it only using one single latent fingerprint, or they were allowed to use multiple view of the latent fingerprint? So
in essence, we thought of each of the 10 fingers as independents, although it's fair to say that's not entirely true, right? I mean, there's likely some correlation between fingerprint patterns. For latents in particular, though, we didn't, we do not yet have ground truth on which finger was left. So if you, I believe the way we actually ran the test, and Elham, I don't know if you're hiding in the room, but you can yell and correct me if I got it wrong. You know, if out of the 10 that we knew were U-matched any of the latents, we considered that a success, and we didn't worry about which 10 it matched.
Well, my question was, even a single fingerprint, typically in a crime scene, you could have multiple versions of that. It's like,
yeah.
Like that. Part of it is missing one latent fingerprint, another part could be visible to others. Sometimes you can put them together, you get more minutiae and figures that match.
So we kept the data consistent by action. So if you look up here, these are some example latents pulled for different actions, and you know, some of them you might have more than one. I think this is an example of one where you in essence got more than one bite at the apple, if you will. But it just depends upon, you know, the action, whether you would have wound up leaving that behind. But certainly you could go look at this and try to say, you know, how do we take all of these different fingerprints that could have been at the crime scene at the same time and use them together? But you're really now more in a matching algorithm question, and the challenge that, as we've done it to date, has not been a matching algorithm question, it's been a capture question.
So among some academics, their credibility and ego is a big issue. So how do you deal with the fact that sometimes people don't want to take part because they're worried about looking bad? And some competitions have had like anonymous submissions and others don't allow it at all. So
yeah.
How do you balance that?
So first of all, I'll say I think you academics, I think you're selling yourself short. I think academics are pretty good about it. I think the Silicon Valleys are the problem, if you want my opinion. When we run things like the face recognition prize challenge, one of the questions I always get is, how does Google compare to all these guys, right? And the answer I have to give you all is, I don't know. And I don't know because Google refuses to participate. Now, if you go push a Google engineer, he will, on penalty of death, tell you there's no benefit to Google to participating in these types of events, because if they win, they basically in their mind confirm what everybody already believes, and if they lose, they look bad, which is kind of what you're saying from an academic perspective as well. My comment for academics is, as a scientist, maybe not academic, but as a scientist myself, we should never be afraid of the truth. And if the truth is you're not the best, then you need to deal with that. Whether that means you need to work harder or go find something else to do is up to you. I personally tend to not worry about that. If you're unwilling to show up for the challenge, that's a pretty good indicator of where you think your technology is.
Any other questions? Oh.
Yeah, hi. I had a question based on my previous experience with the DARPA Revolutionizing Prosthetics Challenge. So that was very different than the computer vision challenges, but having sort of been involved in that a little bit and knowing the people who were very heavily involved in it, I know that there were a lot of things that I guess came up before and after that I sort of started to question some of the prize challenges and some of the challenges in general. One of the biggest things for me was that it seemed like there was a lot of work being done on this one challenge, and instead of collaborating, instead of working together, we were really splitting resources, and at the end of the day, most of this comes from taxpayer dollars, and so it's unclear, if it's better for everyone to be working on, separately on the same project and trying to compete, or if it would be better for, maybe there to be an IARPA collaborative project where we're supposed to, and I know that's maybe more how typical research is done, but I guess that project, for example, afterwards, there was some of the technology went into the DECA arm, but most of it sort of sat there, and there were millions of dollars spent by two different teams that could have otherwise maybe have been put to better use by being, by having them work together. It's a big question, but
So first of all, in terms of whether we're using your taxpayer dollars efficiently when we do prize challenges, DARPA would claim that they get about a 20 to 22x return on investment when they run a prize challenge. Meaning for every dollar they spent running the challenge, somebody else puts in 20 to participate, which is why it's both cost effective and you will all starve if you do nothing but work on prize challenges all day. In terms of dollars, there's ample research that while there may be outliers where people aren't effective with dollars, in general they are. Now, in terms of whether collaboration versus competition is better, I think different problems lend themselves to different approaches. So if you look at, say, the Janus face recognition program versus the face recognition prize challenge, you weren't going to get 5 teams working together over 4 years on a prize challenge, right? Which is what we have under Janus. So in one sense, you get better collaboration, which is good. Prize challenges, I think one of my slides mentions, they're really designed for sprints, right? They're not designed for, we're going to work on this problem over 20 years. They're designed for let's push and see how far we can get. But I also push back a little bit on the notion that because teams are on the same team or on the same program, they actually collaborate very well with each other. That's something that as a program manager, I really struggle with to get my teams to play nice. I won't call out who, but not too long ago, I had one subcontractor bemoaning that the prime wouldn't share stuff with them. That's within a team. We're not talking between two teams, we're talking within a team they're having problems sharing. And across teams they don't collaborate very well either at times. So I'm not sure I would agree that you get better collaboration inherently on a full program versus a prize challenge. You may get slightly better, but I don't know if you can say it's a universal truth. Does that answer your question?
I can talk about it.
Okay.
Okay, we have time for one last question. I guess maybe one last thing that I wonder about is how much time you spend thinking about sort of the optics of how the challenge is going to be seen from the outside, so that the self-driving car challenge, the Stanford scooter, perhaps set back the public perception of how close we were to self-driving cars.
Sure.
And I wonder what you think about that.
So, I think one of my slides mentioned beware, because you can't control the outcome of a challenge, right? Or at least you shouldn't if you're running it fairly and ethically. And that's certainly a risk you run. You may set perceptions wrong. You may appear through the challenge to be indicating that one technological path is better than another, when for various reasons that may not be the case. So in the case of nail to nail, one of the participants had a fairly traditional approach that I don't think would transition well to the real world, right? But it was within the rules that they were allowed to do it the way that they were doing it, and so we let them do it. But you could have an outcome there where the person who wins is kind of counterproductive to what you were trying to do with the challenge. The best thing you can do is have set up the rules well, thought about them in advance, make sure that they're going to serve your goals, and then accept that we're scientists and the outcome is the outcome. Similar to the academics who are perhaps afraid to participate because they might look bad, my answer is, well, if you're, we should all be scientists here, right? Yeah, you might look bad. Figure it out and get better. And I think the same thing is true for challenges. Thank you, everybody.
All right, let's thank the speaker once again.